All right, so this is an intro to graphing circular functions, essentially our trig functions. Now I'm going to go over just the three functions in general here before we actually get into the stuff for this section. This section again is going to be graphing calculator, and they're going to be some kind of weird functions. So they're not going to look like your typical sine, cosine, tangent. We'll come back to the typical ones in section 5, and we'll do stretches and compresses and all that kind of stuff with them, but they'll look like your normal graphs. So to come up with our graphs here, just a reminder, this is coming from our unit circle and from our exact values of our other functions as well, but at least to get a good sketch of the graph here. This point would be over 1 up 0, 0, 1, negative 1, 0, 0, negative 1. And remember, on the unit circle, we're dealing with cosine, sine. So for my cosine, I'm going to fill in this table right here using the values on my unit circle. And then we're going to graph here. So this would be 2 pi or 360, pi or 180, pi over 2 or 90, and 3 pi over 2 or 270. I like to do my graph like this just so I know that my increments are equal or equal-ish. I find that it's easier for me to make them somewhat equal that way. Here would be 1, here would be negative 1. So my angles in this case are my x, my y's are my actual sine values. If we plot these points like we would any other points there, we're going to have 0, 0 here at the beginning. Pi over 2 or 90 is going to be 1, and we keep going. The more spread out your graph is, the harder it is to graph there. And that's my sine function. Of course, it keeps going, but that's the general shape there. In this particular case, this would have a period of 2 pi. The period is the x distance that it takes for you to make a complete cycle. And the cycle is really kind of also the period of the function. It's what the graph does. So in this case, the graph goes up and it goes down. I can see the whole pattern, if you want to think of it that way. The frequency is the number of cycles that you have in a 2 pi span. So in this case, I have 1. And the amplitude is the distance between the midline. Now this would be your midline right here. And either your peak or your valley, your minimum or your maximum. It'll also be half the span of the graph. So this graph goes from negative 1 to 1, which is why that's my range. So half of that would be 1, or again, the distance from the midline to the top or the bottom would also be 1. Also pointing out here, skipped over that, the fact that the domain is all real numbers. I can take the sign of any number that I want to. Okay. So important to remember here, the sine has a period of 2 pi and an amplitude of 1. Now for the cosine function, I can fill in that table using my unit circle. This time, of course, we're looking for the x values. Notice the domain and the range is the same for the cosine. I can still take the cosine of any number that I want to, but the highest that I can get is a 1, and the lowest that I can get is a negative 1. If we throw this one on the graph here, again like the other one, and plot our points, this one is going to start up in the air. And then we're going to go here, and down here, and here, and here. And this is my upside down bell shape. So notice here, period is also 2 pi. That's my complete pattern. Once I get to 2 pi on my graph here, it's going to go down and then back up and do the same thing again. And again, it has an amplitude of 1. That's the distance from that midline to the max or the min, or half the distance that it travels. Now, when we go to graph these later on, like I said, we're going to be doing some transformations with them. We'll be doing shifts and stretches and all that kind of stuff. You need those 5 key points, and you need to know in general what the graphs look like. So sine, we always start at the origin. We end on the x-axis. In the middle, we're on the x-axis, our peak, and then our valley. For the cosine, we're starting up at 1. We're ending at 1. In the middle, we're down 1, and then our middle points. That's kind of the order that I like to graph them in. Whatever you want to do, as long as you can get those on paper. Now tangent's a little bit messed up here, just because of the fact that we're doing a ratio. Sometimes my cosine is equal to 0, so because of that, I'm going to sometimes not have a graph. So this one, notice that the domain, it's written kind of funny here, but I don't have I can't do a tangent of 90 or every other 90. So 90 is out, 180 is good, but 270 is out. And it's essentially the same thing here. The K value means multiples of 180. The range, though, all real numbers. There's no cap on the graph of tangent. Okay, so notice here we're doing some kind of different numbers, but that's because of the way the shape of this graph looks. We're going to back up to negative 90, and we're also going to throw in some 45s here. So for this one, when I graph it, again, we're going to start at our negative 90. This one I'm just going to graph in degrees just to make it a little bit simpler here. So we've got negative 90, positive 90. That's going to be here and here, let's say. So I'm actually going to skip the negative 90 for a minute. Negative 45 would be negative 1, 0, 1. I don't have a graph at negative 90, so I'm going to draw an asymptote line. And I don't have a graph at 90, so I'm going to draw an asymptote line. But my actual graph is going to come down here, go up there. Sorry, that came out a little funny there. Try it again. There we go. So it kind of twists up, kind of like a cubic function through the middle. Then it's going to skip that 90, then it's going to do the same thing again. Then it's going to skip that 90, and so on and so forth. You do still have 5 key points here. You've got the asymptotes. You have your point here, and your point there in the middle. For the most part, when I graph the tangent, I'm focused on the asymptotes and that kind of pivot point there in the middle, and the rest is just kind of a sketch. Now, this one does have a period of 90. That's how fat that cycle is. It's going to repeat itself after that. I'm sorry, the period is pi, 180. We're going from negative 90 to 90, or negative pi over 2 to pi over 2. And there is no amplitude. The amplitude has to do with how tall the graph is, kind of, and there's no cap on this graph. It goes on forever. All right, so now we're going to look at this stuff in the graphing calculator. So what they're going to ask you to do is to solve. So in this case, we want to solve the sine of theta is equal to 0.4, and we want to do that from negative 360 to 360. So you can see some screenshots here on your paper of what we're going to be doing. Now, of course, I can do this just by doing an inverse sine, but then I'm going to have to think about all the quadrants and blah, blah, blah. So we can do it in the calculator instead. Now, this is in degrees because it says, well, it doesn't actually say degrees, but it should. We'll put some degree symbols there on that. So let's go to the calculator here. And first of all, let's make sure that our calculator is in degree mode. And just so happens that mine is. Of course, if yours isn't, go there to the word degree and hit enter. Now the window, it told you what window to use. I want to go from negative 360 to 360. So I'm going to go from negative 360 to 360. And I'm going to go by 45s. Think about your regular graphs there. Normally you're going at increments of 90. So I'm just going to drop it down a little bit here. For my minimums, I'm not really sure what it needs to be. Well, no, I do know what it needs to be. This is a sine graph. So sine goes from negative 1 to 1. I'm going to go from negative 1.5 to 1.5 just to give myself a little bit of space here on the graph. But you could go by more if you wanted to. And I'm going to go by 0.5. Don't worry about any of the rest of that there. Okay. So I guess actually it would help if we put a graph in there. Let's do that. Come on. There we go. Okay, so clear out whatever else is in there. And I'm going to type in 2 things. I'm going to type in the sine of theta, or the sine of x. It doesn't matter there. And then I'm going to type in 0.4. So essentially what I'm going to do is I'm going to graph both of these, and I'm going to look to see where they cross. That's going to tell me every place where the sine is equal to 0.4. So we graph. There's my pretty sine function. And then here comes in the 0.4. And I can see here that I've got a few different places where it crosses. It crosses here, and here, and here, and here, and that's it. Now, 360 to negative 360 is what I was doing. If it looks like it's really close, you might need to actually make your window a little bit bigger so you can see if it crosses right there on the edge. So what I'm going to do now is I'm going to go to calculate, which is above the trace button, and I'm going to go to intersect. I want to see where these graphs intersect. So I'm going to go to number 5 and then go to one of your intersection points. Now it's going to ask you a couple questions here. What's your first graph? What's your second graph? Where do you think they cross? Well, if you go to where you think they cross, you can just hit enter and answer all those questions in one spot. There's my first curve. There's my second curve. Here's where I think they cross. So there's one of my answers. Now we're doing this, it says to the nearest degree or to 3 sig figs for radians. So I'm going to have one answer right here at 24 degrees. Now to get another one, just keep going here. We'll just keep going to the right just to find this one over here. I'm not going to go through and find all of them, but you need to do that, okay? Now look at your, like I said, look at your window here. So if you don't use the window that they've given you, you might be tempted to find answers that are not allowed. So if for some reason I graph this to say 700 degrees, I'd have to be sure that I don't give any answers that are past 360. Okay, so this will be another one, 156 degrees, and so on. So you can see on your notes here, okay, those are the 4 different places where it would intersect. Now, it's really going to be no different than that for the other ones here. So for B, I've got the cosine of x. Now this time, though, I'm in radians, so I'm going to have to switch the mode of my calculator. So I'm going to go to mode and go down here to radian. Okay, so now we're going to go to our y equals, clear what was in there before. And again, just type in both sides of your equation. So we've got a cosine of x on one side. And on the other side, I've got a 0.25x minus 0.3. Now, of course, you do want to double check that you've typed that in there correctly. My window for this one, I'm going to have to change my window to. This time I want to go from negative 2 pi. Now, as soon as I move away from that, it changes it to a decimal. That's perfectly fine. To 2 pi. I'm going to go to like by 45s, like I did before, but this time it's going to be pi over 4. My minimum, I don't know what it needs to be. I'm just going to leave it. And if it looks like my graph's cut off, then I'll change it. I don't always know what the range needs to be. I just sometimes take an educated guess. Okay. So here we go. Now, if you notice down here, oh, it already switched it. But if you notice a minute ago, right here, it had a kind of a crazy graph. That's because it was graphing it in the window of the degrees, which was not obviously what we wanted it to be. Now, looking at this, I think it's pretty obvious to see on my graph here at least that the graph does not intersect right there. It's just intersecting in one spot. If you're not for sure, though, what you can do is you can zoom in. So you go to zoom and go to zoom in and then actually move to that spot. Now, you can also do a zoom box. If you've never done that before, you can just say that I want to zoom over a certain area. Now when I get here, it's not actually going to zoom in until I hit enter. Okay, sorry about that. I had to pause for a minute. So what I did was I moved to where I wanted to zoom in and then I hit enter. And you can see now that, yeah, definitely they're not crossing. Now, of course, I could see that before, but the picture that I have here on the notes, it's not real obvious. Okay, so it does intersect in just one point there. In this case now I've zoomed out, so you can zoom in or zoom back out from where I zoomed in here. It's not going to be exactly, actually it's nothing like the same. We would go to the window here and we would have to change the window. So just for sake of time here, because I'm running out of time to record the video, I'm going to stop it here. But notice when I did my zoom in, zoom out, come on. I made it unhappy now. Come on. All right, sorry about that. The calculator just crashed. I had to shut it down. So this is what it looked like on your calculator. You're just going to go back to that spot there again under your calculate and go to intersect, and you can find that point. And it turns out to be just 1 point again, which would be x equals 1.5. I would just caution you, I guess, to do the zoom in until after you've found everything that you know you want to find. So I would find that intersection point that you know for sure is an intersection first, and then you can zoom in. That way you don't have to worry about trying to zoom out and your calculator crashing. Okay. All right, so last one here, you can see how this one looks when we graph it. As far as my scale here, this is negative 2 pi and 2 pi. Why did I do negative 8 and 8? Well, let me show you why we did that. Okay, so this one here, we're going to need to fix things again here. I need to be in radian mode. And my window, negative 2 pi, 2 pi. Over 4. Okay, so we had negative 1.5 and 1.5 and 0.5. Okay. My y equals here. That's going to be tangent of theta. Couldn't find tangent for a minute there. Tangent of x, and again, it doesn't matter that it's not theta. And 1 minus x. Okay, so we graph now. Okay, so now when I graph that, I'm not completely sure if it's going to be crossing over some of those other curves. So I really need to make it bigger. So I decided apparently that 8 seemed to be sufficient. So let's just go ahead and look at that. Oh, yeah, be careful. You have to always have a minimum. It's not going to like that. Also, make sure when you do your negatives that you do a negative. If you do a subtraction, the calculator does not like that. It's not the same thing. Okay, so now it's pretty easy to see that, that window it's as far left as I can go, it's as far right as I can go, so I can see all of my solutions now. So I've got one here, and here, and here, and here, and here. So just to remind you again how to find those intersection points, we're going to go to calculate, and we're going to go to calculate, intersect, and then you move to one of them. So this one's close, so we'll find this one here. So again, just go to where they intersect there, and then hit enter again, hit enter one more time. This is in radians, so the radians we're doing to 3 sig fig, so 0.4, okay, 7.9, the 9's going to round up because of the 7 after it, so that's actually going to be 0.480. And we would just continue the same thing. Now, my suggestion would be maybe start at the far left-hand side with your 0, and then continue on this path. It seems to take less time in the calculator if you can just go kind of boom, boom, boom. So let me know if you've got issues with the graphing. Help each other out. Look for things like make sure that when you graph that your plot's not lit up. If it was lit up from doing stats, it's not going to graph correctly. Make sure, like I said, be careful about negatives versus subtraction. The graph's not going to graph correctly like that. Check your window. Make sure that you've got an appropriate window for your, and again, they're pretty much going to be telling you that, so you're not going to have to worry about that, but make sure that you've got your minimum is a smaller number than your maximum, because it's not going to be happy with that, and then that you're in the right mode to begin with. Okay. All right, so if you've got questions, Alex said, help each other out. Otherwise, let me know tomorrow.